Alright, so what we're going to be doing today is we're going to be going over section 8.6, which deals with vectors and using trig functions to help us describe our vectors. So the first thing we have to do is define what a vector is. And what a vector is that it's a quantity with magnitude and direction. It's got both. It tells you how far something is going and where it is going. Okay, so what direction. And when you have a vector, you draw it as a ray. Okay, it's going to have a starting point and an end point. That's the direction in which it's going. The first point, or the starting point, is called the initial point, and the point where it ends is called the terminal point. So as you see here, our initial point is at the origin, and then our terminal point is at, what would that be, 3, 4. So we would say this is the vector 3, 4. Okay, it's just like plotting points on a coordinate plane. Okay, so if we say that's our vector 3, 4, from there we can find the direction and the magnitude of it. So how far is it gone, and then at what angle is it heading? Okay, and so that's what we're going to be doing in this one. So describing this vector. So when you want to describe a vector, what you're going to do is that you're trying to find the points of it. Okay, what are the coordinates of this vector? And so we have a degree of 33 and a magnitude of 15. Okay. Now the main thing that we're doing with this is that we are going to be creating a right triangle. Okay, this is 33, this is 15. Okay, and we want to find what this point is. So we want to find what our x value is, and we want to find what our y value is. And what we're going to use is that we're going to use our trig functions to find those missing values. The y is opposite the 33, which means if we want to use the opposite of 33, so the opposite side and the hypotenuse, if you remember SOHCAHTOA. Okay. SOHCAHTOA. So opposite and hypotenuse would give us sine. So we would use sine 33, make sure you're in degrees, is equal to y over 15. And then from there we would solve it. The x would be cosine because it's the adjacent. So cosine 33 is equal to x over 15. And then we would solve this, and that would give us our numbers. Okay. And so if you were to calculate this through, multiply both sides by 15. Okay, for both of these. Multiplying by 15. We see we get about 12.56 for our x and 8.17 for our y, which means our coordinates for this vertex is, or vector, would be at 12.58, 8.17. Okay, so those would be our coordinates for this vector. All right, now the next one, we're going to do the exact same thing. So now we have degree of 15, magnitude, direction. So we're going to drop this, and that's going to give us our right angle. This is 15, which means that your y is going to be sine again, and your x is going to be cosine again. Okay, so there would be your setup. Okay. The magnitude, in most cases, the magnitude will be represented as the hypotenuse. Okay. So we would set this up and calculate it, and we get these numbers. Okay, so multiply both sides by 65, multiply both sides by 65, and we get 62.79 and 16.87. Now, these are not our coordinates. You have to see which quadrant your vector is in. This one is in the second quadrant, which means that the x value is going to be negative and the y value is going to be positive. And with that, you're going to attach a negative to the x value and a positive to the y value. And that's why we would get negative 62.79 and 16.82. Okay. So you're going to have to make sure you know where it's going to be located inside your coordinate plane, because you have to identify if any of them will be negative and any of them will be positive. Okay. So you've got to make sure that one's negative if it's in the second quadrant. Alright, so here's where the more difficulty comes into play, is when you have these word problems. So a plane lands 98 miles south of its original location and 652 miles west of it. use direction and distance, or distance and direction, to describe the vector. So what we're going to be doing here is that we're going to be describing we're kind of writing it out. We're going to say it has gone this many miles at this angle, north of east, north of south, north of west. Okay. Your normal compass, north, south, east, west, okay, that's going to be like your coordinate plane. Okay. So here's north, here's east, here's west, and here's south. So first thing you'd want to do here is that you'd want to draw the vector on your coordinate plane so you can visualize where it is. Okay. So once we have everything, we've got 652 north, south. So the first thing we want to do is find the distance. Well, the distance is going to be the easy part. All we have to do is use our Pythagorean theorem. So we set up Pythagorean theorem, negative 98 squared plus negative 652 squared, because these are both negative in their respective coordinates. And that gets us about 659.32 miles using Pythagorean theorem. Okay. A squared plus b squared equals c squared, because we're trying to find this, the resultant of it. Okay. Now for the angle, what you'd be using is you'd be using tangent. You'd want to find this angle, okay, and we'd be using tangent. So it'd be tangent is opposite over adjacent, and we get about 8.5. After we calculate this through. Again, using inverse tangent, tan inverse. Okay. All right, so what we would write up is that we would say the plane flew for 659.32 miles, and then it flew 8.55 degrees south of west. Okay, so it flew 8 degrees south of perfectly due west. So that's why we would say south of west, okay, because we went a little bit farther than straight west. Okay. If you had an angle going in this direction, okay, this right here, let's say it was 20, it would be 20 degrees north of east. Okay. Now if you wanted to specify it, let's say up here, let's say this was 30 degrees, you would say 30 degrees west of north, because you've moved 30 degrees west from perfectly due north. So you've got to identify where you're looking for your angles, and then that's going to tell you your south of west, west of south. Okay. Your resultant, okay, so kind of a new word, resultant. What the resultant is that it's the sum of two vectors. So when you add two vectors together, what happens is you get a new vector. If we add a and b, we get a plus b, and that blue is our new vector. Okay, and that is called our resultant. Okay, we've created a new vector. It's kind of like the actual direction in which somebody probably flew. Okay, it's the shortest distance from the original point to the terminal point of the second one. Okay, that's called your resultant when you add two of them together. Adding vectors is very simple. All you do is you add the x's and you add the y's. So vector A, 5, 8, vector C, 1, negative 6. And so all we're going to do is we go 5 plus 1, comma, 8 plus a negative 6. And that gets us 6, comma, 2. And that would be our vector. That is our resultant of our answer. So adding vectors, all you do is you just add the x, add the y. All right, your IRAT, which is Individual Readiness Assurance Test. What this is that you're going to answer these questions and you're going to bring them into class, and we will check over them, and then we'll do more examples in class with this. Okay. So the first one, find the resultant adding those two vectors, and the second one is like the plain one that we did, but we have different. It's a boat in a harbor. Okay, so make sure you get these done and bring them into class, and then we'll be good for vectors.